All right, my name is Emmanuel, and the person that helped me with this project is Victory. And today we'll be going through an in-depth presentation of the Python programming language. Our main goal with this presentation is to give you a detailed and clear understanding of what Python is, why it was created, and how it's used. We chose Python because it's beginner-friendly yet powerful enough for complex tasks. Today we'll cover its history, basic features, and even show you how it's used in real-world programs. Python was created by a Dutch programmer named Guido van Rossum in the late 1980s. He officially released the language in 1991. Guido wanted to build a language that was easier to understand and write than others at the time. Python was meant to be readable, powerful, and even fun. He named it after Monty Python, the British comedy group. Since then, Python has evolved tremendously and became a key tool for modern software development. When designing Python, Godot focused on simplicity and readability. He wanted new programmers to feel comfortable learning it, while still giving professionals powerful tools to work with. Compared to other languages at the time, Python required fewer lines of code to perform the same task. This combination of simplicity and power gives Python a big advantage. Python's straightforward design helped it spread quickly. Over the years, several versions have been released. Version 2.0 in 2000 introduced features like lists, comprehensions, and garbage collection. Then in 2008, Python 3.0 came out. This version made some big changes to fix earlier design issues, like improving Unicode support and cleaning up the syntax. Python also became widely used in schools and universities, especially as data science and AI started growing. Tools like NumPy and Pandas became essential. Today, Python is everywhere. It's used by tech giants like Google, Meta, and OpenAI. Google uses Python in many of its AI tools. Facebook used it to build Instagram, and banks like JP Morgan Chase use Python to analyze financial data. Python is a key player in machine learning, automation, cybersecurity, and even game development. It's also supported by a massive community that keeps creating libraries and frameworks. So in this next section, we will be providing a tutorial on how to run a Hello World program within Python. The Hello World program has a reputation by many for being the first running program. It is also highly regarded as the novice program to help better understand the syntax and logic of the language it was written in. Python, being a high-level language, also makes this process much easier, as well as due to its readability. There are many ways to run Python, but in today's tutorial, we'll be running it through Jupyter Notebooks. So first, you'll have to install Anaconda, which provides everything you need to work with Python, including Jupyter Notebooks and many other essential libraries. And once you have that installed, you will open Jupyter Notebook and you will type in the first cell, print hello world. And that's all you have to do to be able to write your first hello world program in Python. Python is packed with features that make it great for both beginners and professionals. It's simple and easy to learn, especially because of its clean syntax. It's an interpreted language, which means code runs line by line, making it easier to debug. It also supports dynamic typing and worked across multiple operating systems, making it a very flexible language for almost any project. The goal of this next section is to provide some commonly used features in Python. This section will cover paradigms, data types, control flow, expressions, subprograms, object orientation, and exceptions handling and optimization. Python supports several programming paradigms, which means you can use different approaches based on the problem you're solving. It supports imperative programming, where you write code step by step, procedural programming, where you break code into functions, object-oriented programming, which focuses on objects and classes, and even functional programming, which emphasizes using pure functions. Python comes with a variety of built-in data types that help you work with different kinds of information, from integers and strings to more complex structures like dictionaries and sets. Python makes it easy to store and manipulate data. Each type serves a different purpose, and you'll find yourself using them all the time when writing code. Control flow in Python lets you decide how your program runs. This includes if-else conditions, for and while loops, and statements like break and continue. These tools allow you to make decisions, repeat actions, and respond to different situations while your program runs. Mastering control flow is key to writing efficient and powerful programs. In this first example, we have a while loop. Here, we're printing numbers from 1 to 5 while using a while loop. The condition is I is less than or equal to 5, and we increment I inside the loop with I plus equals 1. No parentheses are required around the condition, and indentation handles the block scope instead of curly braces. This makes the loop simple and clean to read. In this next example, we have a for loop. We're looping through a list of names using Python's for name and names syntax. Python handles iteration directly over the list. No need to deal with indices unless you want to. Again, indentation defines the block. It's a minimal and readable way to loop through any iterable. In this last example, we have a if-else statement. We check if the variable age is greater than or equal to 18. If so, we print you are an adult. Otherwise, we print you are a minor. There are no parentheses around the condition, and again, indentation takes the place of braces. Alright, this first example demonstrates how the continue statement works in a loop. We're looping through the number 1 to 5. Inside the loop, we continue to check if the number is using the condition I modulo 2 equals 0. If it is, we use continue to skip the rest of the loop for that iteration. That means even numbers get ignored and only odd numbers are printed. This is useful when we want to filter out certain values without breaking the loop entirely. In this second example, we're using a break statement. The loop goes through a list of numbers and looks for the number 5. Once it finds it, it prints a message and immediately exits the loop using a break. Any code after the break won't be executed for the iteration or any others after. This is helpful when you want to stop processing as soon as a condition is met, like when searching for a specific value. Expressions in Python are the building blocks of logical and computation. They include arithmetic operations, comparisons, logical checks, identity checks, and more. Python expressions are clean and readable, which helps you understand your code better and catch mistakes more easily. Identity expressions used to determine if two different variables refer to the same object in memory. These expressions use the is and is not operators. Function expressions used to store the value returned from a function into a variable. Member expressions used to test whether a single value is in a sequence such as list, tuple, or strings. They use the in and in not operators. Attributes access expressions involves storing a single attribute of an object into a variable. For example, one could store the length of a string object into a variable called length. Subprograms are reusable chunks of code, like functions and methods. In Python, you can define a function once and use it anywhere in your program. This helps you stay organized and avoid repeating code. It's especially useful when working on larger projects or writing modular code. Another Python subprogram is a method, essentially functions, but they are directly associated with objects of a particular class. They can be used to modify an object attributes or return a value. The benefits of subprograms go beyond convenience. They help break your code into smaller, manageable parts. This is known as modularity. They also make your code reusable and hide implementations details from the user, which keeps your code clean and secure. Python is fully object-oriented. This means you can define your own data structures using classes and create objects with unique properties and behaviors. It also supports inheritance, so you can build on existing code and polymorphism, which helps simplify code that works with many types of objects. Python has built-in tools to handle errors using try-except blocks. This helps you manage unexpected events and prevent your program from crashing. You can also use finally blocks to clean up resources and else blocks to run code only when no errors occur. Exception handling is essential for building reliable applications. In this first example, we're creating and using a custom exception called invalid age error. We defined it by subclassing Python's built-in exception class. The checkAge function takes an age and raises this custom exception if the input is negative, something that logically shouldn't happen. If the age is valid, it tells us whether the person is a minor or an adult. And then we test this function inside a try block using an invalid input, -5. Since that triggers a custom exception, Python skips the rest of the function and jumps to the except block, where the where we catch the error and print a custom message. This shows how you can build more descriptive and application-specific error handling into your Python programs. This second example demonstrates Python's built-in try, except, and finally structure. We tried to divide 10 by 0, which raises a zero division error. Instead of letting the program crash, we catch the error with the except block and print a friendly message. The finally block is especially important. It always runs, whether or not an exception occurs. In real applications, this is where you'll release resources like closing a file or a database connection, ensuring your program cleans up after itself. Python also supports many ways to make your code faster and more efficient. You can profile your code to see what's slowing it down using high performance libraries like NumPy, and even integrate with C using Cython. Tools like PyPy can speed up execution with just in time computation. You can also use caching built-in functions to reduce operations.
So in section 5, we're going to be talking about the medium program implementation. The goal of this section is to showcase the potential of Python when de developing a decent sized program. So basically, we're going to be using Python to create a program that is going to show how flexible, easy to understand, and how powerful Python is. And it's basically going to be a program that wouldn't be so long but contains a lot, showing you how much Python can simplify complex codes. Next, we're going to be talking about the basic design. So this is going to be like this basically just gonna cover how this program was designed. So basically, this is a weather app that I made on Python. It's basically an app that uses some of Python's library, like the request library of Python, to interact with information on the internet, and then send us back basically the request that we asked from the internet. So basically, the weather app is just how we send requests to the open weather app, and then it sends us back in JSON format the temperature, like the information about the weather of the specific city that we put in. So this is the code showing us the how the program, the Open Weather app was made. So this code basically explains all the steps that I took to making this weather, and we can see that the code is just a 22-line code, and it shows it's a code of a weather app that's able to pull information from the Open Weather app and display that information based on the input of the city that the user puts in. So first of all, we look at the import request. This is one of the libraries of Python that I used. First, I had to do the pip install request on Python, which was pretty easy, and it just basically installed, gave us some access to be able to use requests. So what request does, it's able to give us the ability to be able to interact with the internet to send a command there that we need a specific information through the hypertext transfer protocol, and then using the API key that we specify, those information that we request from the internet, specifically in this case the Open Weather app, is able to be sent back to us through JSON JavaScript object notation, which is then like transcribed and put into values, or a way that we can understand in this program. So it's going to be written out in this format, which is basically like a JSON format. So the next thing there is the get weather, the function. This function is basically going to use the specific name of city that we put in, and our specific API key here to interact with the Open Weather app using the base U RL that we put in here, and then it's gonna use the params, like basically the city name, to be able to pull in information that we need. So in this case, we put the unit as imperial. So basically, it's gonna pull back for us information in Fahrenheit, which is for imperial, or if we put in metric, it's gonna pull back information for Celsius. And then next we have the request.get. So this is basically just how we're able to use the params that we put in the RL that we put in to be able to draw information back and displayed based on what the user imputes. The response status on code equals to 100 is just basically telling us that if this is true, then sorry, if this is right, or if this is like correct, like basically display the weather, temperature, and also display the description of the weather in that particular city. Sorry, I kind of stuttered, so that's why I'm like taking time to explain this. And if there are any errors, our else statement here is gonna basically tell us that there was an error with basically maybe the user puts in a wrong city name, or basically if the wrong API key was used. So the API key here is a real one. I had to go on the Open Weather app and create my own API key because that's gonna be able to generate real-time information for us. So basically the weather that we see here, the 72.86 degrees Fahrenheit, is basically a real-time weather, and that's basically what my phone is showing right now when I run it. So it's giving us actual information. So this code basically is just a 22-line program, like I said, and it's able to run it's able to give us such a complex information in a very simplified way, and that just explains how easy and better Python is compared to other programming languages. So we can see here that I used the indentation and all of the stuff that I've been explaining in the previous slides. And so yeah, basically Python just it's the best pretty much. We didn't need to use so many parentheses or specify types of values. Python just knows most of those things, and it cuts the process really short. So this is a program that's basically explains how Python can do complex stuff in a very easy way and in lesser time. Evaluation of Python in section 6. So this is just basically telling us the goal of this section is to evaluate Python with respect to its features, because Python has so many like nice features compared to other languages like C++ and Java, which are more complex. So we're gonna dive into all of these features that Python has that makes it stand out compared to other languages. First, we have simplicity and orthogonality. So the simplicity is just basically telling us how easy Python is to be read and how less complex it is, because Python was originally made to be easy. Like you can easily just look at it and like understand it. And the orthogonality here tells us how Python is able to combine different features without having errors. So you can combine integers and strings, and you won't really have issues when you run them, unlike some programs where you have to basically specify what kind of types those values are. You have to specify if they're integers or strings before you run it. Specifically in C++, you have to do that a lot. Next, the control structures. Python provides a standard control structure, so like the if-else statements, the else-if statements, the for loops, the while loops. These are all very important control structures that Python supports. These control structures are easy to use and follow. Overall, Python provides a clear, concise mechanism for control structures. So basically, if you're using the if condition, you don't really have to like put in like the semicolon or the parentheses that Python, sorry, that Java or C++ needs when you're working with them. All you have to use here is the indentation, and that basically makes it work without spending so much time on it. So this is also one thing that makes Python quite easy to use. Next, we have the data types. Python has a wide range of built-in data types encompassed in the four main built-in data types of Python. So basically we have the numeric, the sequences, the binary, and the Boolean. The numeric is divided into basically three, like that. Those are the main important ones that we basically use every time. So example of this, no, this numeric types are integers, floats, and complexes. And an example of the integers would be like whole numbers like 1, 2, 3, -1, -2, -3. Examples of the floats could be like decimals, so 3.142, which is basically pi, and complex, which are numbers that have or values that have imaginary and real parts. So we have an example of that could be 2 plus 1j, 1 plus 3j. So all of those type of integers or values are complexes. And then for the sequences, it's a list of ordered uh, components or items. And example of the sequences could be strings, which are basically mutable types, and they normally in square braces. And tuples are also types of sequences. These ones are represented in parentheses, and lists are also the same way as well. And all of this, like tuples and lists, are basically um, immutable, which means that they cannot be changed. And then for binary, we have bytes, byte arrays, and for Boolean, we have basically the true and false statements. And then we have the Python, basically because of those data types, provides so much flexibility, as we can see, and it allows programmers to solve large and complex program in a simple code, just like we could see in the sample project that we did. Just in 22 lines, we were able to create a very complex program that didn't even take us so much time. All we had to do was just learn how to use the API in the Open Weather app. And then we can see an example here. So basically, this is just an example showing us how data types in Python can be dynamically typed, which means you don't really have to declare the type. So you could just put x into x equals 5, and it basically during runtime tells you that that is an integer, or it kind of like knows it's an integer. And then if you put x equals hey, it basically knows already that that is a string. You don't really have to specify. Syntax design. This just tells us how Python's syntax is pretty easy and more concise than other programs like Java. We can see an example here. Looking at Java, you see we need parentheses and curly braces just to write a simple program. With Python, all we need is just basically just call the if statement, and then using a colon, you can use indentation to just put your codes, and it basically runs. You don't need the parentheses and the curly braces. Python also uses very consistent syntax. So for the if, while, and def, all uses a colon to denote the start of the code, followed by the indenting block. That's what we see here. Basically, the colon followed by the indented block of code. And next, we're going to talk about the support for abstraction. So Python provides a strong support for abstraction functions and mo modules, encapsulates reusable codes, organize codes into related sections. Python object orientation provide ways to write more structured and abstract code. So looking at this example that we have here, so we defined calculate area as a function. So it means that basically when we're writing a code, we can just identify what what a function does, and we don't really have to like recalculate the area every time. We could just call the function calculate area radius, and it gives us basically the calculation again without having to rewrite the 3.14 times radius. So basically we can reuse codes without having any complications. That's also one important use of Python. Next we have expressivity. Python is very expressive and offers a large variety of features. Example, dynamic typing. So basically, like I explained earlier in the previous slides, you don't really have to specify the type of the values. Python automatically knows when you type in like x equals 5, it knows that's an integer, or y equals victory, it knows that's a string. And some of the features Python also promotes functional programming, like the lambda expressions is basically just like a way to give certain function like a standard that they're to be used. So x could mean x times x, and basically all of the numbers in a specific list are just going to use that same function. So it like gives values in a list a specific function to which they're to work with, and then the map filter and reduce functions are also quite important. So basically Python uses this map to basically add functions to values in a list. The filter is basically to select numbers or stock or items from a list with specific conditions. And Python has a robust library like the NumPy request, like we used in our program, and NumPy and Matplotlib help us like draw tables and stuff. The NumPy is just for calculation, like math stuff, and all of those kind of like arithmetics. Next, we have type checking. So what this does is basically Python tries to check so that we don't like so that a code doesn't see an integer as a string. So Python checks that at runtime to help us know that we're using the specific type for the right values. Basically, and it does this during runtime, which is quite important. And next we have exception handling. The syntax of exception handling in Python is very clear and concise. It uses the try and except block, which allows programmers to handle exceptions gracefully. You can also handle multiple different exception following a try block. So basically the try block would just basically tell us what the code is about, and then the except is going to tell us when there's an error, and then just throw in the error basically, and just like we explained in the previous slides above. So next we're talking about restricted aliasing. Python, unlike C++ and other languages which even have the restrict function, does not have many restrictions on aliasing, meaning multiple variables could refer to the same object in memory. This has its good sides and its bad side. The good side of it is like multiple variable names can refer to the same object, so data does not have to be like copied over and over into different memory. It makes it easier to modify objects like lists and dictionaries, which are pretty much uh, table, and it allows objects to be passed by reference. The bad side of this is basically it's gonna make the code more difficult to debug, because if you're using mutable sequences and you have so many variables being copied to the same um, object memory, is gonna be hard. Like it's gonna be hard to debug, because if you make any mistakes, it just affects the whole code, and it's hard to go back and find all of those areas where you made these mistakes. Next, section 7 is the reflection. This project is deep in understanding of both Python and other languages as a whole by comparing Python to other widely used languages like Java and C++. We've gained insight into the importance of key features like syntax, compiler, behavior, and dynamic memory management. Understanding these elements has helped us better evaluate the strengths and weaknesses of Python programming language and make more informed decisions about the um, language best suited for a given task. So basically, this project has basically shown me how it's basically told me that my favorite language is Python, because it's pretty easy and like it's not as complex as C++, because I first of all learned C++ before I learned any other language, and C++ is just kind of like complicated. You just have to write so much functions and write so much, like declare so much variables and so many things, and with Python you just got to do all of those complex things in a small line of code. And that was why I specifically chose the project that we used for this program, because it was just 22 lines of code and it covered so much. So basically Python is one of the best ones, if I would say. And next we're going to talk just the references sections about where I got all the in, informations about Python that I used, and all of this is this was very important and like useful when coming up with all of the versions and everything about Python. So I think we covered everything. Thank you.